How many cases have there been? Oh, tell me. There have been 3 cases, right? Now write case 4. Case 4 will be our active methylene group. Put the heading, write active methylene group. What is an active methylene group? CH2. In between 2 minus M groups. If there is a CH2 specifically, be at between 2 minus M groups, we call it an active methylene. Write this down. Active methylene group means CH2 in between 2 minus M groups. So tell me, if we have this diketone, can you identify which one is the active methylene? Here, the CH2 in the middle. If an H plus is removed from here, the negative charge will resonate on both sides. So it is between 2 CO groups. This is called a M. M means active methylene group. All right, now tell me, is the active methylene more acidic? Or is the alpha hydrogen of a ketone more acidic? Between these two, which one is more acidic? Active methylene or alpha hydrogen, tell me. Here, when you remove an H plus ion, a carbanion will be formed. Is this carbanion resonance stabilized? It is, right? It's resonance stabilized, isn't it? Similarly, when you remove an H plus ion from this, a carbanion will also be formed here. Is this carbanion resonance stabilized? Yes, it's in resonance, right? Here too it's in resonance, and here too even more so. How many resonance structures does this have? 3 resonance structures. And how many does this one have? 2 resonance structures. So which one is more stable? The first one. The first is more acidic. So active methylene is more acidic because the negative charge on both sides undergoes resonance. Did you understand? So write down. 1. Active methylene is more acidic than the alpha hydrogen of a ketone. Why is active methylene more acidic? Because of the presence of 2 electron withdrawing groups applied in both directions on both sides. Write it down clearly. Active methylene is more acidic because of 2 electron withdrawing groups. Similarly, write a second example of this. And tell me, is there any active methylene group in it? Tell me. There is, right? An active methylene. Which one is it? The left one, they say, the middle one, the bottom one, or the top one? The top one. The top one, this is the active methylene. If I say this is an active methylene, upe, and this is the alpha hydrogen of a ketone, then tell me which of the 2 is more acidic? Active methylene. Let me give you another example to help you understand. Active methylenes are more acidic, because there are electron withdrawing groups on both sides. And minus M is directly proportional to acidic by strength. Out of these 2 alphas, which alpha hydrogen is more acidic? Look, there's one thing you need to keep in mind. This ester here, the ester itself is a resonance stabilizer. It's already in resonance on its own, right? That means it's already content by itself. So if you create a negative charge here, will there be effective delocalization with the ester? It won't happen because it's already resonance stabilized itself. But what about ketones? In a ketone, a negative charge will form here. Its minus M effect will easily apply. That is, this is a C double bond O. It will easily resonate with this negative charge. Whereas here, the minus M effect won't operate as easily. It does operate, but it's very weak, almost negligible. Do you understand? So which effect will you consider? If you create a negative charge and resonance occurs, then it becomes more acidic. Here, when a negative charge is created, yes, in an ester, its minus I effect comes into play. Its minus M effect is poor. All right, let me share some data about this with you. For example, we have this ester, right? I mean, an ester is kind of like a self-serving person. You know how some people are like that? Actually, most people are. So this ester bond is content just resonating with itself, enjoying its own resonance, you see. So if I ask you to compare the resonance energy of these two, you'll find that the resonance energy of both is equal. That is, the resonance energy of these two is equal. Why is it equal? Because the ester won't resonate with this alkene since it's already content, resonating with itself. Did you understand? I don't remember the exact data for this, but it's probably approximately minus 78 kilojoules per mole. This is the resonance energy data, and it's almost equal for both. So whenever you consider any effect of an ester, you should take the dominating effect. Which one will you consider for its acidic strength? You should neglect the minus I and minus M effects. Do you understand? Okay, there is minus M, but it's not. Sometimes it happens, right? Something is there, but it's really not like that. Did you get it? What kind of compound is an ester? You shouldn't be friends with people like esters. So whenever you see an ester, just consider its minus I effect and neglect the minus M effect, because it's already involved in resonance with itself. And I shared this data with you to show that in reality, it resonates quite well on its own. It just doesn't interact with others. Has everyone written it down? Write about esters in Hindi. Esters by themselves is carefree. Shall we move ahead? All right, now let's take two examples by mixing both of these concepts. So you have to compare their acidic strength, right? One is our diketone. One is our ketoester, and one is our diester, ester on both sides. So tell me, what will be the order of acidic strength among these three? Go ahead, speak up. This one has actinthin in it. This is also called actinthin. But if I ask which effects will operate on both sides, when the carboxyl group forms, there will be an M effect here as well. There will be a M effect here as well. That's how it will be, right? What effect will be there in this one? Since it's a ketone, there will be a M effect. And when a carboxyl group forms here, which effect will be present? Minus because I, right, will neglect the M effect. So tell me, what will happen here? Yes, when this one looks like ester, then which one does it look like? Minus I, minus I. Technically, this is also called activating, but we won't count its M during Aikin effect. So tell me, what is the answer for acidic strength? R is greater than B, which is greater than C. If you look at the pK values, they are 9, 11, and 13. There's that much difference, 9, 11, 13. The pK value keeps increasing, right? So when you replace the ketone with an ester, what happened to the acidic strength? It decreased. Did you hear the last statement? What did you hear? When you replace the ketone with an ester, what happened to the acidic strength? It decreased. You have to compare the acidic strength of all four of these. What's the answer, bro? Who will come first? B. Who comes after that? After B comes D, then A, then C. How did you figure that out? First of all, B is our active ethylene, right? There's minus M on both sides, isn't there? So in B, we'll write minus M to N minus M. 2 minus M will be placed inside the conjugate. Then in D, a carboxyl group will form here. So the ketone will have minus M. And what will the ester have? Minus I. Then in A and C, in A there's only a ketone here, right? So minus M, and for C, minus I. That means if it's keto, monoketo, identiketo, and monoester, then the ketone is more acidic, right? And if it's a ketoester and a monoketo, then the ketoester is stronger. Overall, the ones with 2 withdrawing groups will be stronger. The ones with 1 withdrawing group will be weaker. Withdrawing means minus M, minus M. Did you understand? Did you note it down? How many cases are there? There are 4, right? Now, if you would, write the 5th. Now, please write the detailed case 5 if you could. What is the case? We'll discuss that now. Tell me, which hydrogen is more acidic? Is the hydrogen in cyclopropane more acidic? Or the one in cyclopentadiene? Tell me. Out of these two, which H is more acidic? Tell me. The second one. How? If we just remove that H plus, what will be formed behind? Tell me. An important aromatic compound will be formed, right? And if you remove H plus from this one, what will be formed? Anti-aromatic. So the first is more acidic. So now which concept will we apply here? What will be the variable here? Aromaticity. Similarly, in the second case, tell me, which is more reactive toward base? Out of these two, which is more reactive toward base? Whose reactivity toward base is exactly higher? When considering reactivity toward base, what do you need to look at? Tell me that. You need to see which one is more acidic. It's the same thing, right? If I ask you to compare acidic strength or compare the rate of reaction toward NaOH, it's basically the same thing, isn't it? So overall, tell me, out of these two, which one has the more acidic hydrogen? So we will remove the H plus from this one, because when a negative charge forms here, it will be fully delocalized through resonance. So if you remove this H plus, the conjugate that forms will be resonance stabilized, right? Similarly, if you remove this hydrogen, for example, in this context, then what will the conjugate that forms be like? Tell me. Resonance stabilized. So tell me, what will happen next? Tell me, which one is more stable? If you do resonance with this carboxyl group, then a carboxyl group will appear here. So how many pi electrons will form a loop? 8 pi. There are already 3 pi bonds, right? A negative charge will appear. When you do resonance in this, what will happen? Tell me. If you do resonance in this, you'll get an important aromatic compound. This time it's not forming directly, it's forming only after resonance. In this example, it was forming directly. In this, resonance will occur, and then this important aromatic compound will form. So what answer are we getting, brother? First, both have the same reason, important aromaticity. So case 5 is our aromaticity case, in which the aromatic nature can be variable. All right, now write further. How many cases have we covered? So write case 6. We are living in a very happy and good country. So thank your parents and your country. Let's go. Tell me the order of acidic strength in this. As you go from left to right, is the acidic strength increasing or decreasing? What difference does it make to the acidic strength when going from here to here? And what difference does it make when coming from here to here? Speak up. All right, tell me, if you remove H from this, what will be left behind? C minus, N minus, O minus, and F minus. So when you go from left to right, we say that electronegativity increases from left to right, and acidic strength also increases. So who is the most acidic among them? HF. And who is the weakest? Methane, because its electronegativity is increasing, right? So F minus is the most stable. So when can you apply the concept of electronegativity? When hydrogen is attached to an atom that belongs to the same period, all right? And tell me what will happen if you come to the group. When you remove H, what does it form? F minus, B, Cl minus, Br minus, and I minus. Out of these 4, which one is the most stable? This is F minus, then Kl minus, then bar minus, and then I minus. So when we go down the group, size becomes important there. Electronegativity matters when the sizes are comparable. So out of these 4, which one will be the most stable? Tell me, brother. I minus. So what do you need to look at in a group? In a group, you need to see that as size increases, acidic strength increases. So when does this size concept apply? When hydrogen is attached to an atom that belongs to the same group. Okay? For example, if I ask you to compare the acidic strength of H2 or H2S and H2T, what will you consider here? Electronegativity or size? Size. So which one is more acidic? H2T is then H2S, and H2O is the weakest acid among them. Did you understand? When hydrogen is attached to an atom belonging to the same period, consider electronegativity. For the same group, consider size. Write this down. I has a bigger size, it's already stable. That means electronegativity in the same period and size in the same group. Write 7. Tell me this. Is acetic acid more acidic or is phenol more acidic? Is acetic acid more acidic or is phenol more acidic? Oh, just leave it like that. Is acid more acidic or is water more acidic? Acid, right? Acid is more acidic. Phenol? Of course, acids will be more acidic, right? It's called acid for a reason. We'll get to the chemistry later. First of all, it's called acid. Now tell me, why is acid more acidic than phenol? Yes, because how many resonance structures will its conjugate have? Tell me. 2 equivalent resonance structures. So the ones with acid, in their name, are more acidic. So this one has 2 equivalent resonance structures. The acetate ion is more stable. So understand that the one with acid in its name is simply more acidic. For example, tell me, is sulfonic acid more acidic? Or is carboxylic acid more acidic? Say it. Sulfonic will be more, right? Why will the sulfonic be more acidic than phenol? But 3 equivalent RS and carboxylic A conjugate has 2 equivalent RS and carboxylic A are more acidic than phenol. Why? Because it has equivalent resonating structures while the other does not. Which is more acidic, phenol or alcohol? Phenol, because its conjugate is resonance stabilized. Its conjugate does not have resonance. So there is a general order. Sulfonic, carboxylic, phenol, alcohol. Conjugate of sulfonic S3 equivalent RS. Did you understand? There was a song in the movie 3 Idiots, right? What was the song? Which acid burned away my childhood? Yes. Astana said it, right? He said sulfuric acid. Why didn't he say that carboxylic acid burned away his childhood? Why? Why didn't he say that water burned away his childhood? Or phenol burned away his childhood? You won't really get burned by those, right? You'll burn much better with a strong acid. Do you understand? The most intense pain on the body in the world, which kind of pain is the most unbearable? Like if someone slaps you, hits you out of anger, pokes you with a stick, or pinches you. So, what kind of pain is there on the human body that is the most painful? God forbid anyone ever has to go through that. That is a pen. Burning pain. When a person gets burned, you know? You must have seen it sometimes, right? People get burned in accidents. That is unbearable. It means that pain stays all over the skin. A person can't move, can't do anything. It's really horrible, isn't it? So you must have seen it sometimes. Firecrackers go off or a vehicle. When someone gets trapped in an accident, they get burned. All right? Now write a small heading. Just one last small heading. I'm writing this for you in the table, right? You need to memorize this. For the next class, write it 3 times and bring it. Right there. Order of acidic strength. In the order of acidic strength, there's S2F plus and SBF6 that actually this is formed from HSBF6. Atomic acid, fluorantimonic acid, this is not just an acid. This is the acid of acids. Meaning just like Superman is the man among men. Similarly, Superwoman is the woman among women. then comes sulfonic. After that comes hydrogen. Write these down and remember them. Order of acidic strength. By the way, I had asked you to watch that PK1. Did you see which was the strongest acid in that? It was this antimonic acid, and which was the weakest? Methane, alkane, 50. Very good. All right. So first comes hydrogen. After hydrogen comes carboxylic. After carboxylic comes phenol. What was the pK of phenol, brother? 10. 10, very good. Phenol is almost comparable to SCM-SAR. It is almost comparable to RNH3+. And if you want to compare it even more, it's almost comparable to active methylene. And the pK value is, phenol is 10. Then water is more acidic than all alcohols except methanol. Water, methanol, water. Then comes ethanol. You have to write the pKa values for all of these after watching that pKa song. Then comes the ketone. Then comes alkyne. Greater than ammonia. Greater than alkene. What was the pKa of ammonia? 36. Water is more acidic than all alcohols except methanol. What is the pKa of alkyne? 25. You should remember this. These are all the main functional groups. You should remember all of them. I mean, even if you don't remember the exact data, that's fine. But you should at least know roughly the range in which it lies. For example, all alcohols are in the range of 15. Acids are in the range of 5. Phenol is in the range of 10. Acid is 5. Phenol is 10. Alcohol is 15. So in the next class, there will be questions based on this. Right now, which IIT is ranked number 1 among all the IITs? Which IIT holds the number 1 ranking in the US rankings? Number 1 is IIT Delhi. This was in the latest news today. The world ranking is 171. That's that. And in India, IIT Delhi is first. And IIT Bombay was in 3rd place. Sir, it was in 3rd place, right? Then who was in 2nd place? Kharagpur. IIT Kharagpur was probably in 2nd place. Yes, here it is. IIT Delhi is first. IIT Kharagpur is in 2nd place. IIT Bombay is in 3rd place. IIT Kanpur is in 4th place. IIT Chennai is in 5th place. In 6th place is DU, Delhi University. In 7th place is ISC Bangalore. And in 8th place is VT Vellore. And in 9th place is Manipal, Mah. And in 10th place is Bob Anna University. Patna isn't included in this, man. Why are you asking about IIT Patna? It's not included here. These are India's top 10, and in the world ranking, IIT Delhi is at 171. Kharagpur is at 202, Bombay at 234. There are a lot of factors involved. You know, those are the factors. Children, how many students are studying there? There's the children to faculty ratio. And then there's also a point for infrastructure. We're not lacking, but they've set their own rules. They're the Western ones, right? They make these things based on intelligence, like whose mind is sharper. We come first. Got it, brother? So tomorrow you have to write this 3 times and listen to the pK value explanation 3 times as well. You should have it completely memorized. How many types of alcohols there are, how many alkynes, and what acids are. All right? Because you'll get a lot of questions of this type where we can compare acids, carboxylic acids, so you should have an idea. Okay, this one is more acidic than that. All right, which is more acidic, alcohol or alkyne? Which alcohol is more acidic than alkyne? All of them are, right? So what kind of doubt arises? It comes up like this. Since oxygen is more electronegative than sp carbon, then you think, here there's a plus sign, the plus sign has increased. Even now, why is this more acidic? So if the plus sign has increased, it means the pKa has gone from 16 to 18. Even now, alkyne will always come after alcohol. Did you understand? That's why you should know the data. All right. So we'll meet again tomorrow. Okay? Okay then. Jai Hind.